Alright, geometry students, so today we're going to finish up that worksheet that we started last week, and we were working with 2 and 3D shapes. We talked about area and how the area relates to the volume of the shape. So just remember we filled out this nifty little thing here, and we had all the formulas. We started by finding, we started by looking at 2D shapes last week, and we did the triangle, okay, that had a side of 12. But anyway, now we're going to continue on, and we're going to do some more of these shapes. So part B, okay, on this actually says to find the area of the following shape. So here, it's a hexagon, and if you remember, just look at your formula, okay, and just plug in what you've got here. So the formula for the hexagon, the area, equals 3 root 3 over 2 times the side squared. So all you got to do is plug in, the side is 5, nice and easy, so 3 root 3 over 2 times 5 squared. 5 squared is 25, okay? So if that is equal to 25, then just basically you've got 3 times root 3 times 25, okay? You can't really do the 25 times the root 3 as far as combining them or anything, but you can combine the 3 out in front. So 3 times 25 is 75, so we have 75 root 3 over 2. And being as this was feet, that means area is feet squared. Okay, so that's all you have to do for that one. Then we have the next one. Again, just pause the video if you need to write down the work that I had on these. You'll want all the work shown. Okay, so for the circle, it asks for the area. And I'm just going to write that up here because we're going to actually talk about the Ferris wheel that we're going to go on Friday. So for the area of a circle, on the formula sheet, it was pi r squared. So right here, r is our radius. On this one, we know that our radius is 13. So all you have to do is plug in pi times 13 squared. 13 times 13 is 169, so that means you have 169 pi. You always write your number out in front of the pi, okay? And then again, since it's area, it's centimeters squared. Oops, here we go. All right, so there's that one. For the Ferris wheel, however, it's a big Ferris wheel, right? I looked up online, and the radius of this Ferris wheel is actually 100 feet. That's just the radius. So the diameter across, all the way across, is 200 feet. So when you go up to your highest point on the Ferris wheel, okay, when you ride this thing, you'll be 200 feet up in the air, roughly 200 feet up in the air, okay? We have to also factor in, like, you know, how far off the ground we are in the starting point. So I think it ends up being around 204 feet. But anyway, we could ask some questions about this. For example, we could ask what the circumference of this Ferris wheel is. Like maybe like they had to buy steel to go all the way around this thing. What would it be? Like how much steel would you need as far as feet goes? We could talk about the area maybe that it takes up. Okay, so let's do a couple of those things. So for this particular thing, for sky view, so this is again the sky view Ferris wheel, we have circumference equals 2 pi r. All right, so 2 times pi times the radius. So again, circumference, we just fill in the r, so it's 2 pi times 100, remember the radius is 100. And so that's 200 times pi. So 200 pi is what we would normally write it as. But if you want to kind of get an idea of what that is, remember 3.14 is pi. So if you multiply that by 2, that's 6.28. And then add 2 zeros. So that's 628 feet all the way around that Ferris wheel. So let's say they were wanting to know how much steel, maybe just to go around the Ferris wheel, in a straight line, it would be 628 feet. Now, if we wanted to know the area maybe that Ferris wheel takes up, just the front of the Ferris wheel, let's say, not necessarily the volume, but the area, we could do, again, pi r squared. We could use that for our area. And all we have to do is put in 100 for r. So it's going to be kind of a big number, though, because that's 100 squared. Okay, so 100 times 10 is 1,000. So 100 times 100 then is 10,000. So that's 10,000 pi. And then if you multiply that out, you get this. So that's a pretty big number. Not that pi. Wrong area for the comma here. 31,400 will be your the area. It would be feet squared. Okay. And then finally, let's say we were dealing with maybe the volume. Let's say the width of the gondola, each of the gondolas, maybe straight across, like the depth of it, let's say it's about 6 feet. So basically you would just take this area, okay, you take the area, so for volume that it takes up in the park, take the area that we just got and multiply it by 6. We multiply it by the depth. So whatever that is, 31,400 feet squared times 6, and then that would end up being the volume that took up in the park. Another thing I wanted to talk about, I can do it on the back here, well, I might have to do it over here, just write this down, is the fact that we have 42 gondolas on this thing. Okay, so I want to know what the angle is between each gondola. Okay, so if I were to think about that, I've got like I said, 42 of these things, so there's no way I can draw all those well, but going all the way around, I've got 42 of those things. So I want to know, again, what the angle is between each of those. What's going to be the angle in between everybody's gondola, and then we can figure out the space between the gondolas. So what you would have to do is how many degrees are in a circle? So you know there's 360 degrees in a circle. So if I take that, I take 360 and I divide it by 42, I'm going to get the amount of degrees that are in between each gondola. And when I get that, I end up getting about 8.57 degrees. Okay, so between each gondola, between each space here, you're going to have about 8.57 degrees. How wide is that, like, in terms of circumference? We want to know, like, how long would that be? You know, what would be the space in between the gondolas? So if we think about that, remember, the distance around is the circumference. We know that our circumference is 628 feet all the way around. So what would be the distance from one gondola to the next? That's our final question. So again, a rough estimate anyway. That's about 9 degrees, so we'll use 9. Okay. Or we can think, if you want to actually, we can think of 40, like 1/42nd of 628, that will actually help us determine if it's, if we take 628 and divide it by 42, we'll get the space in between each gondola. So I'm going to do that right now. That'll be the last thing we talk about on the Ferris wheel here. So 628 divided by 42 is 14.95. So 14.95 feet. That's how far apart each gondola is. So that's kind of interesting. So just something to think about while you ride it. Continuing on though, you've got some more problems that you'd have to do. I can do a few of these with you, but we're going to want to, I can't do them all. You're going to have to do a few of these on your own. So I think you have, from here, we have 3 all the way to number 10 on here. I think we only have 10 problems total. So we've already done 2 of them and talked about the Ferris wheel. And so I'll do a few more, and then you guys can finish the rest. So again, on this one, it says find the radius of a circle with circumference of 31.42 inches. This is a little different. The key to this is look right here and think, okay, circumference. What is the formula? So go, okay, circumference for a circle, so that's another thing. Circumference for a circle, C equals 2 pi r. And then think, okay, they gave us the circumference. So instead of just filling in the r, we can't do that. They want us to find that radius anyway. We don't have it. So we actually have to fill in c, because they gave us the circumference. So instead of the c, I'm going to put 31.42 equals 2 pi r. And then how do I get r by itself? Well, I have to get rid of what's out in front of r, which is 2 pi. And since that's being multiplied, when it's right next to it, it's being multiplied. So since it's being multiplied by it, what's the opposite of that? Dividing. So I have to divide both sides by 2 pi. And then when I do that, again, if we use like 3.14 for the pi, I'll just go over here, 2 pi equals 2 times 3.14. If we just use that, being as they're giving an approximation as well, then 2 pi actually equals 6.28. So really I'm dividing both sides by 6.28. So I'm going to do that now. So 31.42 divided by 6.28. And I end up getting 5. So for this side, I end up with a 5, and over here, the 2 pi's cancel each other, and I get r by itself. And then again, you can just rewrite it as r equals 5, but 5 equals r is the same statement. It's completely okay. So yeah, so then my radius for that circle would be 5. And it would be inches because they said that the circumference was in inches. Alright, so again, some of these are pretty easy. Find the volume with a base area of 25 and a height of 15. That's actually kind of nice because remember, the volume equals the area of the base times the height. No matter what prism you have or what shape you have, it's usually the area of the base times the height. Well, they gave you the area. They said it was 25. So they're just giving you this. We don't have to write down any particular formula for a triangle, nothing, because they already gave you the area of that triangle, basically. That's what they're saying. So we've got this triangular prism. It looks like this, if you remember. Okay? And there, remember, that's the area of the base times the height of this thing. So they're saying this area right in here, they're saying that that is 25. And then now they gave us the height. So the volume of this thing is just 25 times 15. Okay? And then you'll have whatever that is. Let's figure that out. 25 times 15. 375. And just remember, we have volume here. Volume is in cubic units, basically. So we have inches here. It would be inches to the third power, being as its volume. So basically, look at the rest of these. Try to complete 5 through 10. Okay, I'm going to look on here and see if there's anything weird. I'll just kind of talk through it. Find the volume of a triangular pyramid with the base area of 25 and the height of 15. Well, that looks really similar, but remember, what's special about the pyramid? Okay, remember that I was telling you, if you have a shape that comes up at a point, you take a third. Okay, you take a third of the volume that you would normally take for the prism that goes straight back. You would take a third of that. So this should be a third of this. And that's what you should have here. How do they compare? It should be a third, but just check based off of your equation. Just make sure that's right. Find the volume of a triangular prism. Again, they give you the area and the height, so go ahead and do that one. Number 8. Find the volume of a triangular pyramid, and then they give you the area and the height, so talk about that. And then how do the volumes of the prisms and the periods relate? We already talked about that answer, so make sure you just think about that, what we talked about, prisms versus pyramids that come to a point, right? How is it reflected in the formulas? Just write a sentence about it. And then how do you think the volumes of the cylinder and the cone relate? Same idea, so make sure you have that written down as at least one sentence for that one. Okay?